Let's try to tackle this question. So press pause and have a quick read. You've been given the first three terms of a geometric sequence. You've got to find a common ratio, show that k satisfy this, and find possible values of k, r, and values of r which will lead to a sum, and blah, blah, blah. So I'm expecting you to know this formula. So let's try and do this. You've been given the first three terms. That means you start here and then you times by a common ratio, because that's the geometric sequence. So you times by the common ratio, and if you want to know what this ratio is, get the destination divided by the start. So r must be get the destination divided by the start, and then if you want to know, you got to show that k satisfy this equation. Well, if you look at the second term, and then you times by the common ratio, which is this thing here, must give you this. So start with 4, the second term, times by the common ratio, this thing here, 4 over k minus 4, must give you this, must give you k plus 2. So for the first one, it would be 4 over k minus 4. And then to show this, tidy this up. This gets multiplied to the top, giving you 16. And then tidy this up, times both sides by k minus 4. So that would then be this, k minus 4. That would be 16 here. And then now clean this up, multiply this out. This will be k squared. I'm going to do in one go in my head. You're going to get minus 4k and another 2k, so that will be negative 2k, negative 8. Now add 16 to both sides, so that will be, take away 16 from both sides, that would be negative 24. This side would be 0. So that's the second part done. So find possible values of k. So now it's just a matter of solving this. Two numbers multiplied together to give you 24. You know you've got to work out, hang on, let me just move it in screen, 24. So you know you've got to work with 6 and a 4, because a 6 and a 4 you can create a negative 2. Well, anyway, factorize this. This will then be k minus 6 and k plus 4 equals 0. So that means k could be 6, or k could be negative 4. So what that means is, if you let's test it out to understand what's going on. If k is 6, let's put 6 into the k here. So that would be, the first term will be 2, and then 6 into here. Oh, it remains as a 4, and this would be 8 when you put 6 into the k. And the common ratio when k is 6 would be 4 over 6 minus 4. That would be divided by 2, which in turn leads to 2. That means the common ratio is 2. Hang on. That means that the common ratio is 2. Now let's check it. It all makes sense, because look, the first term is 2. You times it by 2. This is our common ratio. It gives you 4. Now 4 times the common ratio gives you 8. So you see, this k here makes sense. Everything makes sense. Now let's look at k equals negative 4. So hang on. Let's look at negative 4. So our common ratio earlier was 4 over k minus 4. Okay, let's look at the case when k is negative 4. When you put negative 4 into the k here, this will be negative 8. 4 remains as 4. Negative 4 into this k here would be negative 2. Let's have a look at the common ratio when k is negative 4. So the common ratio would be 4 over negative 4 take away 4. So that would be 4 over negative 8, which means it's negative a half. So our common ratio is negative a half for k equals negative 4. So let's try and let's try to make sense of this. So you start with your first term, you times by this common ratio, negative a half. It does indeed give you 4. Look at 4, times by the common ratio again, negative a half. It does give you negative 2. So, so everything here makes sense. When k is 6, the common ratio is whatever, and the whole thing makes sense. When k is negative 4, the common ratio is whatever, and the whole thing makes sense. So possible values of k must be k equals 6 and k equals negative 4. Possible values of r, well, we just looked at it earlier. It could be negative, it could be negative a half is a possible value of r. And what was the other one? The other one was 2, I think it was. R could be 2 because you would use 6 and put it into here. Hang on, let me think. Well, whatever it was, possible values of r, and if I will continue in the next video. Okay.